The following content is provided under a Creative Commons license. Your support will help MIT OpenCourseWare continue to offer high-quality educational resources for free. To make a donation or view additional materials from hundreds of MIT courses, visit MIT OpenCourseWare at ocw.mit.edu.
All right, let's begin. So as I mentioned before, this lecture will be recorded for OCW. So again, in future lectures, if you don't want to have the back of your head show up, just don't sit in this front area here. So first of all, wow, what a crowd, you guys. We're finally in 26100. 6111 made it big, huh? So good afternoon and welcome to the very first class of 6111 and also 600 this semester. So my name is Anna Bell, first name Anna, last name Bell. I'm a lecturer in the ECS department. And I'll be giving some of the lectures for today, along with later on in the term, Professor Eric Grimson, who's sitting right down there, will be giving some of the lectures as well. Okay, so today we're going to go over some just basic admin trivia, a little bit of course information. And then we're going to talk a little bit about what is computation. So we'll discuss at a very high level what computers do, just to make sure we're all on the same page. And then we're going to dive right into Python basics. We're going to talk a little bit about mathematical operations you can do with Python. And then we're going to talk about Python variables and types. So as I mentioned in my introductory email, all the slides and code that I'll talk about during lectures will be up before lecture. So I highly encourage you to download them and to have them open. We're going to go through some in-class exercises, which will be available on the slides. And it's fun to do. And it's also great if you could take notes on the code, just for future reference. It's true. This is a really fast-paced course, and we ramp up really quickly. So we do want to position you to succeed in this course. So as I was writing this, I was trying to think about when I was first starting to program, what helped me get through my very first programming course. And this is really like a good list. So the first thing was I just read the P-sets as soon as they came out, made sure that the terminology kind of just sunk in. And then during lectures, if the lecturer was talking about something that suddenly I remembered, oh, I saw that word in the P-set and I didn't know what it was. Well, hey, now I know what it is, right? So just give it a read. You don't need to start it. If you're new to programming, I think the keyword is practice. So it's like math, or reading. The more you practice, the better you get at it. You're not going to absorb programming by watching me write programs, because I already know how to program, right? You guys need to practice. So download the code before lecture, follow along, whatever I type, you guys can type. And I think also one of the big things is if you're new to programming, you're kind of afraid that you're going to break your computer, right? And you can't really do that just by running Anaconda and typing in some commands. So don't be afraid to just type some stuff in and see what it does. Worst case, you just restart the computer, right? So yeah. So that's probably the big thing right there. I should probably highlighted it, but don't be afraid. Great, so this is pretty much a roadmap of all of 6001 or 600, as I've just explained it. So there's three big things we want you to get out of this course. Okay, the first thing is the knowledge of concepts, which is pretty much true of any class that you'll take, right? The class will teach you something through lectures. Exams will test how much you know. This is a class in programming, right? The other thing we want you to get out of it is programming skills. And the last thing, and I think this is what makes this class really great, is we teach you how to solve problems. And we do that through the P-sets. So that's really how I feel the roadmap of this course looks like. And underlying all of these is just practice. So you have to just type some stuff away and code a lot. And you'll succeed in this course, I think. Okay. So what are the things we're going to learn in this class? I feel like the things we're going to learn in this class can be divided into basically three different sections. So the first one is related to these first two items here. So it's really about learning how to program. So learning how to program is, part of it is figuring out what what objects to create. You'll learn about these later. How do you represent knowledge with data structures? That's sort of the broad term for that. And then as you're writing programs, you need to, programs aren't just linear. Sometimes programs jump around, they make decisions. There's some control flow to programs. So that's what the second line is going to be about. The second big part of this course is a little bit more abstract. And it deals with how do you write good code, good style, code that's readable. So when you write code, you want to write it such that you're in a big company, other people will read it, other people will use it. So it has to be readable and understandable by others. So to that end, you need to write code that's well organized, modular, easy to understand, right? And not only that, not only will your code be read by other people, but next year, maybe you'll take another course and you'll want to look back at some of the problem sets you wrote in this class. You kind of want to be able to reread your code, right? If it's a big mess, you might not be able to understand or re-understand what you were doing. So writing readable code and organizing code is also a big part. And the last section is going to deal with, so the first two are actually part of the programming in Introduction to Programming and Computer Science in Python. And the last one deals deals mostly with the computer science part in Introduction to Programming and Computer Science in Python. So we're going to talk about, once you've learned how to write programs in Python, how do you compare programs in Python? How do you know that one program is better than the other? Right? How do you know that one program is more efficient than the other? How do you know that one algorithm is better than the other? So that's what we're going to talk about in the last part of the course. Okay, so that's all for the sort of administrative part of the course. So let's